All right, welcome to some algebra or algebraic consequences from our, chopping off of a lot of the graph of the inverse to make the inverse of whether it be sine, arcsine, or arccosine, or arctangent. To make them a function, you have to basically get rid of a decent chunk off them. So there is some consequences. I'm just going to show it to you on an example. So in this example right here, we have an arc cosine of, or an inverse cosine of, cosine of 2 pi. Well, a lot of times what it's trying to get you to do is be like, oh, that's an inverse of a function. These cross out, and the answer is 2 pi. But not so fast. Let's do it a little bit slower and actually follow Gemma and see what happens. So to follow Gemma, I have to do what's inside of the parentheses first, right? Inside of the grouping symbol. So that means I'm going to have an arc cosine or an inverse cosine of, cosine of 2 pi. I mean, that's a 1 right there. Now, the next question is, so I've evaluated this, and this is what I have. So now ask yourself, what is arc cosine of 1? So we go to our cosine graph and we say, well, at 1, like right here, if I plug in 1, I'm going to get an output of 0. This equals to 0. So you say, wait a second. How is this 0? If I plugged in 2 pi, shouldn't I get 2 pi? Well, yes, but 2 pi is outside of the range of our cosine. We can never get 2 pi out of our cosine. So you will get the equivalent of 2 pi because 0 is coterminal to it. It produces the same result for cosine. So this right here is your answer. So in summary, at first, you may think that our cosine will simply undo the cosine. Sorry, not the sine here. Sorry, that was a bad autocorrect. So the cosine. But actually, when you solve the problem, you'll notice that due to the restrictions of the domain and range, things are not quite as they seem. So it's not quite that simple that you get just to cross it out. Sometimes it will be, sometimes it won't. So what you need to do is first evaluate the inside and then evaluate the outside. So let's see. Let's do two more here. So we have arc cosine of 1/2 is on the inside. So I'm going to evaluate that first. So I'm looking for 1/2. What angles produces 1/2 on here? So basically I'm looking at the first two quadrants. And to get 1/2 in the first two quadrants, this will be 60 degrees. And what is cosine of 60 degrees? Well, cosine of 60 degrees is 1/2. So notice here they do cancel each other out. Right, and I'm looking at the next one here. Sine of 9 pi over 4. Well, sine of 9 pi over 4 is the same thing as reference angle of pi over 4 in the first quadrant. So, right, reference angle of pi over 4 in the first quadrant. So 45 in the first quadrant. So that is square root of 2 over 2. So I need an arc sine of square root of 2 over 2. And arc sine of square root of 2 over 2 is, basically 45 degrees, which is pi over 4. So again, it's not the same as 9 pi over 4, but it produces the same result. So that is pretty much kind of it over here. So watch yourself. Good luck. Let's finish these up over here. When you do, really quickly, pause me, do them. Here, I'm going to post the answers, so share the answers with you real quick. Right there. I should have done this one with you together because it's kind of cruel. This one has no solution because the first part is simply not possible. You cannot plug in a 2 into an arc sine because, look at it. There is no 2 here. There is no 2 as an input. That's not possible. Sine can never produce a 2. Therefore, arc sine can never take a 2 in. So your answers here is your negative pi over 2. So negative 90 degrees. And right here is they actually do cancel each other out. Hopefully you are okay with this, following my instructions of doing the middle first and then doing the outside. The alternative to this, is kind of annoying. It is learning all of these rules, which I don't like learning rules. I rather do logic, and this is what I explained to you here. Just want to kind of share this with you, that this is what a lot of textbooks show, and they say, oh, there are 6 cases. If this happens, then this. I say, nonsense, don't worry about it. Practice this. It will take you a lot further, and then eventually these kind of will make sense, and you will know them without really having to study them. So I wanted to do one more example with you with something a little bit tougher, like down here. So we have, sine of arc sine of 0.9. I mean, this is not something you're familiar with, right? But think of it this way. So we can create a triangle that represents this, right? And, well, the triangle would be, it looks like it's positive, so in the first quadrant. And that triangle, again, not in a unit circle, but I would say this triangle would have a 0.9 here and 1 here, because that's the ratio they're giving me. Or you could claim that that triangle would maybe be a 9 here and a 10 here. That would be possible as well, but the ratio is basically a 0.9. And this is the angle then referring to. And then, so the answer to this question right here would be this angle. So therefore, what we have is this results in sine of arc sine of 0.9 being basically sine of this angle. Well, sine of this angle, if we were to look back, sine of this angle right here is 9 over 10. So the answer is 9 over 10, which is 0.9. Ta-da! All right, I think a lot more of these are more standard. So good luck. Let's get sample problems 2 done here. And there is some more practice below over here. All right. And if it's not possible, because that might be, just state why and you'll be good. All right. Good luck. Pause me and I'm going to have some answers up. If not, they're on my website, of course, but I do think I have some answers up for you. So make sure you get them done. But here are really quickly the answers.